Alright, so I took video of our discussion in class, but there was too much kind of side conversation going on that I think this will be best. So I'm just going to do a recap of the 10.5 through the 10.8 review that you're going to want to do for this test. We're going to finish up the journal that I had you start on Thursday, and you're going to be finishing up doing journal sections on 10.5 to 10.8 here. So I'm going to start with 10.8, and what we did in this journal is we made sure we wrote down each section and what it was called. So 10.5, as you can imagine, would be about factoring x squared plus bx plus c. The directions, the main set of directions that you're going to see for a section like this is to solve the equation by factoring. So in your journal, what I would write to yourself is if you ever see directions like this, the first thing to know is that you're going to need to factor. So you're going to need to solve the equation by factoring. So this is what I would write down. You will first need to factor. And if you need to, once again in this journal, you're writing down whatever it takes for you to recognize when I give you a set of instructions, you need to recognize what to do for it. So if you're going to first need to factor, because it's saying use this factoring method to solve the equation, you need to understand what factoring is and understand that when we factor, we take it from a standard form equation and we write it into factored form. So rewrite a standard form equation as factored form. So this is standard form up here, and what we're going to want to eventually get it is into something like this: x minus some sort of value, I'm just going to call it r, and then x minus some sort of other value, I'm just going to call it s. Okay? Or it could be plus, keep that in mind. But this would be what we consider factored form because there's two factors. Okay, so you first need to factor it, and then you need to refer to 10.4 if you need to 10.4, but to actually solve, set each factor equal to 0 and solve for the x. Okay. One thing to note is 10.5 is all about a equaling 1. So if you look at this right here, it's going to never equal like 2x squared plus 3x plus 4. It's always going to be 1. Okay, so we're going to look at a problem for this, and the first problem that I had everyone do in class was number 19. That's a 21. Okay, so the first thing that you're going to need to do to factor this, and remember you're writing down whatever it takes to remember, but you are going to get it into this form of x and then minus or plus something, x minus or plus something, and those two somethings need to multiply to be your c because this is standard form, so it needs to multiply to be this last number, and when you take those numbers and add them, they need to add to be negative 21, the center number. So the most challenging thing about this problem is to come up with the factors that are equaling 108. So keep in mind you always have 1 and 108. Okay, so think about it like this. You could do 1 times 108, that's going to equal 108. You could do negative 1 times negative 108, but whatever you do, if you're going to put those in there, if I wanted negative 1 and negative 108, yes, they multiply to be 108, but they do not add to be negative 21, so I don't want those. What about 2? 2 will also go into 108. It's an even number, so 2 and let's think, I should chunk these together. Okay, so 2 times what is equal to 108? Well, 2 times 54. Okay, you can always do this in your calculator. Do 108 divided by 2, see if there's a whole number that can multiply with 2 to be 108. So once again, this is positive, so it's either both going to be negative or both going to be positive. And I will tell you, you want two negatives because when you add them together, you want a negative. Okay, so if I do -2 and -54, they're going to multiply to be 108, but they don't multiply to be -21. So I need to keep going. 3 and 36, we could try that. You're going to run into an issue with that as well. If you do -3 plus -36, you do not get your -21. 108, does 4 go into it? Yes, it does. 4 goes into it 27 times. So once again, -4, -27 doesn't work. 5 doesn't go into it. You can check it. I just did 108 divided by 6, and it's equal to 18. So 6 times 18, 108. When I put those in, 6 and 18, yes, they multiply to be this, but they don't add up to be that. So that's not going to work. 7 doesn't go into it. I checked. 8, I can check 108 divided by 8. Nope, 8 doesn't go into it. 108 divided by 9. Okay, that's going to be 9 and 12. Okay, so if I take 9 and 12 and I plug it in, 9 and 12, did I just factor this correctly? Check it by FOILing. If you do fronts, you get x squared. If you do outsides, you get -12. Plus, if you do the insides, -9. That's going to be, or -9x, -12x. When you add those up, do they equal -21? Yes, they do. -9 plus -12 equals -21. Multiply those last, you get this last, you're set. You got 108. So I'm going to set that equal to 0. Keep in mind, you're solving for this. To solve now, after you've gotten into the factored form and check your work, make sure when you FOIL this out, you do f plus o plus I plus L. It does equal to this in the end. I'm going to set each one of these factors equal to 0 now. And this is all from 10.4. It's that zero product property, because if this factor is equal to 0, then that's going to make this whole thing go to 0. So we would have found an x value that would make this true. If x minus 12, if this chunk or this factor equals 0, then this whole thing goes to 0. So x equals, when I add 9 to both sides, I undo the subtraction of 9. I get x by itself. I get x equals 9. Plug that in. 9 minus 9 and 9 minus 12, what you're going to get here is 0. And what you're going to get here is -3. But regardless, 0 times -3, that equals 0. So that's what we're looking for. This is a value for x that will make the statement true. Add 12 to both sides, get at that x. X by itself would just equal x equals 12, x equals 9. Because if you plug 12 in, you're going to get 0 as a factor. 0 times anything is 0. Alright, so that's number 19. What I also had students do is number 21. I'm going to give you a hint for this one. 21, when you're looking at this, they have x squared plus 26x equals -169. One thing to note is that when we're factoring, we're taking it from standard form and putting it into factored form. In order to be in standard form, everything has to be collected to one side, and we want this thing equal to 0. So you're going to notice this isn't in standard form. We need to collect this term over here. So in order to get this off of this side, you could either subtract -169, or you can just do the opposite of adding 169 to get this -169 negated or countered off of this side. But whatever you do to one side, you have to do the other. So we get x squared plus 26x plus 169 is equal to 0. Okay, so now it's in standard form. Now you're going to want to get it back into factored form, or get it into factored form. So again, we know that we're going to start with these x's because a is equal to 1 here. It's easy enough. You just start x times x. We're going to get x squared. Right, but now we need to figure out what are two numbers that multiply to be 169 when you take these last numbers of each one of these factors. When you multiply them, they'll equal this last number. So I'm going to give you this answer, but I do want you to go ahead and finish this off. If we chose 13, there's a very limited amount of numbers that multiply to be 169. You could go through and try to run through the list like we did up there, but you're going to get really a few values. The answer here, this is not quite done. You're going to need to carry it further just like we did up here. Okay. Alright, so now we're moving on to 10.6. What that has to do is when we're factoring ax squared plus bx plus c. In your journal to yourself, what I would note, a is not going to equal 1. Look at the difference between your problems 19 through 21 on the previous page in 10.5 and then versus the 22 through 25 set, those problems. What you're going to notice is all of these, the a was equal to 1. When you looked at the standard form, a, or the number attached to x squared, was equal to 1. In these ones, that is not the case. Alright, so I'm going to write 2-factor 10.6 problems, or these problems where a does not equal to 1. You're going to have numbers in front of your x's. So you need numbers in front of your x's. So for example, remember, you're writing these problems down so that you can use them as reference. If I look at number 22 here, I have 12x squared. That's the thing. A does not equal 1. A equals 12 here. Plus 7x plus 1. Okay, and notice this isn't equal to 0 this time because the directions, oops, I need to write that down. It says factor the trinomial. So make sure you write down the directions so that you can see what you did for these directions in your journal. Okay, so once again, I'm going to break these into factored form, but I'm going to leave room because there's going to have to be a number in front of the x. And what those numbers need to multiply to be is this front number out here. So the front numbers, whatever you do for these two factors, these two clumps that I'm looking for, the two front numbers are going to have to multiply to be 12x squared. So really, I have x times x, I got the x squared, but what times what equals 12? So this is where it takes some guessing and checking. If you wanted to, you could do something like 3 and 4, because those definitely multiply to be that 12. Okay, you could have had 6 and 2. That might be another option. Okay, but then after you've figured out what two numbers multiply to be that front number, so the front numbers of your factors, here's a factor, here's a factor, what you're going to look for are now the two numbers that are going to multiply to be 1, and you're very limited here. Okay. In class, this is actually going to get you it. So to check this, you're actually going to FOIL this out, because remember, to go from standard form to factored form, you factor. Okay, that's what I did here. To go from factored form back to standard form, you FOIL. So you do the fronts plus outsides plus insides plus lasts. So if you multiply the fronts, you're going to get 12x squared, and you ensured that when you picked those numbers 3 and 4 and had those x's out there, you ensured that that's what you would get when you multiplied the fronts. So that's good. Plus outsides, I'm going to do 3x times 1. That's going to be 3x. Plus the insides multiplied, so 1 times 4x, which is 4x, plus the lasts. You also ensured that you would get this last correct, but these are the ones that I have to check. Do these actually multiply to be 7x? And yes, they do. So this is the correct factorization, or correctly factored. So here I correctly factored this. Alright, so number 22, that's what it's looking for. At the beginning of class, what someone did do, we actually tried 6x plus 1 and then times 2x plus 1. We were close. When you do and check that through, you would have gotten 12x squared, then plus outsides, which is 6x, plus insides, which is 2x plus 1. But when you check that, those don't match up to be the 7x, so this would not be correct. You would not want to put that as your final answer. So on your test, you could just X that out and then attempt another combination of numbers. Alright, the other one I had kids do for this one is number 24. I'll leave you to that one. Alright, 10.7, factoring special products. Okay, so this I kind of did on my own. I didn't use the book, but you're going to want to, it says use factoring to solve the equation. What I wanted you guys to get out of this chapter, and these are the directions, and what this means is, once again, you need to factor. Okay, and then once again, set each factor equal to 0, and solve for the variables. Okay, so same thing as what we've been doing all along, but so in these two, this one right here, all we did was factor. Okay, we didn't have to solve. Look back to 10.5. What we did do was solve there, so we factored and then solved. But what 10.7 is, there's special products. So what you need to watch out for is watch out for the pattern x squared and then minus b, where b is, I should actually say c, minus c. So c is a perfect square. And recall the list of perfect squares that we've studied. A perfect square would be, for example, 4 because it's 2 times 2. 1 would also be a perfect square because it's 1 times 1. 9 because it's 3 times 3. Perfect squares are any number that when you take the square of it, so 3 squared equals 9. 4 squared, or 4 times 4 is 16. 5 squared, or 5 times 5 is 25. You want to be careful of x squared minus one of these numbers because there's a special way you can factor them. So an example of this, and I didn't actually do numbers from your review, I did my own, so this you could call Goddard 1 or G1 problem. If I have an x squared minus a 16, what does that equal? So we're trying to factor the directions is use factoring to solve. So the first thing I need to do is factor. And I think on the test you might be startled because it's not that trinomial that we're used to where it's a term plus a term plus a term, or a term plus a term minus a term. It's just two terms here separated by subtraction. But what you're still doing is you're still looking, a is 1 here, you're still looking for, alright, what multiplies to be negative 16 and adds to be, in this case, 0, because there is no middle term. There's a 0b here, or a 0x here. So we're trying to figure out what multiplies to be negative 16, and this is the special pattern that you're looking for. Because it's a perfect square, you can use the same number, 4 and 4, and then negate 1, make 1 positive, because negative 4 times 4 is negative 16. Add those together, that's when you get a 0x. If you want to FOIL that out to check it, do it. Fronts, x squared, plus outsides, 4x, plus the insides, negative 4 times x, negative 4x, plus negative 16. There we have it. These cancel each other out just like we wanted because we don't want a middle term. We don't want an x in here. And then we get x squared plus negative 16, which is the same thing as that. Alright, keep in mind we're not done because the goal, it said use factoring to solve, so now we need to set each one of these factors equal to 0 and find what values of x will make this whole thing equal 0. So when I set x minus 4 equal to 0, if this factor equals 0, this whole thing goes to 0. So I'm going to add 4 to both sides. We get x is equal to 4. There's one solution. This one, x plus 4, set that equal to 0. Subtract 4 from both sides to get at what just x is equal to. There's a solution. Keep in mind also, if I ever ask for you to do x-intercepts, solutions are the x values of the x-intercepts. If you need to write that in your journal somewhere, do. I've said this countless times. Solutions are the x values of x-intercepts. So if you have your solutions, you can come up with the x-intercept very easily by just plugging it into the form 4 comma 0. Because remember, x-intercepts are where it crosses the x-axis and always the y equals 0 point. So you just figured out an x value for when y is equal to 0. So here it is. And you just set this whole thing equal to 0, so you found x values that will make that actually true. So negative 4 comma 0 is the other x-intercept. This is if I ask for x-intercepts. So if I ever do, keep in mind, you're going to be seeking the solutions really, because the solutions are the x values of the x-intercepts. My other one that I post for this one is to solve by factoring, once again, x squared minus 100. Okay, so I'm going to kind of start you out, x and x. Alright, come up with two numbers that multiply to be negative 100 but add to be 0. And it's going to be a special kind of thing where it's just a minus and a plus, I can tell you that, and a special number. You're going to think what times what is equal to 100. It's a perfect square, so it should be the same number. Finally, 10.8, and this is actually what that worksheet is that I gave on Monday. 10.8 is factoring using the distributive property. The directions that are oftentimes associated with this is factor completely. That is what your instructions will say. Okay, so one thing that you're going to have to be doing here is the first step for these, if it ever says factor completely, this is where we do find the GCF, find the greatest common factor, or the GCF, of each term in your polynomial by factor trees. You're going to pull this term out and pull the GCF out. If you know that each term has a certain factor in it, you can pull it out. Okay, and then just make sure you cannot factor what is left. So you're going to be left with some sort of polynomial, and you, just like up above, you're going to look at that polynomial and say, can I factor this any further? Can I take this polynomial that's going to be in standard form and rewrite it into even smaller factors? Okay, so the example I'm going to do for this one is number 30. I'm going to have you do 29 on your own. I think 30 is more difficult. So 30, it's going to be 2x to the fourth minus 32x squared. Okay, so here I go with my factor tree. This is the first step that I would have written in my journal. You break them up. The first branches should just be the number branch and the letter branch. Okay, if you want to change this to plus and negative, that's fine. Okay, so this is going to be negative 32 and then x squared. This right here can't really break down anymore. If you want to, you can do 1 and 2. Okay, but I mean really 1 and 2, it's just going to keep repeating itself. This is prime, so it's the only things that it can break down into is 1 and 2. Alright, this right here can be, oops, this was to the fourth, excuse me. So this is going to break down into an x times an x times an x times an x. This right here is a negative, so I am going to do it into negative 2 times and then 16. This could break down into negative 1 times 2. Okay, can't go any further. That's all we have for that. We have 2 and 8. This can be broken down into 2 and 2. This can be broken, 4, sorry, 2 and 2. Okay, so I'm going to kind of circle all these. These are the most basic prime numbers that it can break down into. These are all the basic prime numbers that they can break down into. This right here also can branch out to be x times x. Okay, so now what we're going to be doing is finding out what do they have in common. So I'm going to do a different color here. We're going to do blue. Okay, so when I'm looking at everything that's in here and every one of those prime factors, you're going to find out what's in common. Well, they both have two x's, so I'm going to circle those. Okay, and they also both have a 2, so I'm going to take a 2 from here and then take a 2 from here. That's all they have in common. I couldn't circle anything. I couldn't circle another 2 because this one doesn't have another 2. So the GCF is 2x times x. So 2 times x, or you can simplify that to be 2x squared. So if you were to rip those off the tree, what do you have left? Well, what I have left is 1 times x, that's going to be x squared. Check that. If I take this times this, do I get my first term? Because this is my new first term with that 2x squared ripped out of it, okay, or factored out of it. Okay, so I take this factor. What do I have left? Well, x times x. So make sure that they check out. If you take 2x squared times x squared, yes, I get that. Plus, we're going to move on to this next one. If I rip those out, I'm just going to rip them off my tree. What do I have left? Well, I have negative 1 times 2 times 2 times 2 times 2. That's going to be negative 16. Make sure that this checks out. So if you distribute this back in, that's part of the idea of why this is called factoring using distribution. If you were to check this, multiply 2x squared times x squared, yes, I get that. Plus 2x squared times negative 16, yes, I get that. So I've done this absolutely correctly. All right, now here's the thing. This is just a monomial, that's done. We can't do that anymore. But can you look at this thing that's left after I've ripped out that common factor? Can you look at this and factor this anymore? And what I need to tell you is this is it's a square, x squared minus a perfect square. So this is going back from that just previous section that we just did and saying, all right, can I rewrite this? And I most definitely can, because it's hopefully that pattern that you'll see from all these problems that we've done. Can you recognize this as something that you can factor as minus 4 times x plus 4? Because when you take those, multiply them, you get negative 16. When you add them, you're going to get that 0 term in the middle. Alright, so that's it. I would encourage you to do number 29 as well. So don't forget to do these problems that I've left open. Okay, so do this one as well. Make sure you solve. The key things that you're going to be doing is factoring, solving, adding and subtracting polynomials, that's from 10.1, and then multiplying, which is from 10.2, and actually multiplying transfers into FOILing, and that's this whole entire chapter. Can you multiply two factors together? So, I mean, when we multiply these two factors, do we get this? Okay. So I'm going to leave you with that. The more of these problems you do as review, the better off you'll be. But these are the problems that you hopefully will journal about. Write whatever it takes for you to understand. If you have a certain set of directions from a certain section, you're going to write whatever it takes for you to understand where to go from there. So if it says factored completely, know where to go from there. Have an example for yourself ready to go to see what you did. Okay.